Hey everyone, so today's learning target is I can calculate the mean and standard deviation of a sampling distribution. So it says, how tall do you need to be to play in the NBA? Well, it depends on the position you want to play. In this lesson, we will try to find the average height for all power forwards by taking a random sample of 5 power forwards. So right now, I want you guys to answer the question, what is the population? So the population is all the powered forwards in the NBA. Okay, that's the population. So what is the sample? What are we really looking at? We're looking at the 5 powered forwards. Okay, now I want you guys to refer to the handout that has all the heights of 115 power forwards, and I want you to look at the distribution at the bottom left. What kind of shape is that? So the shape is approximately normal. Okay, and now what is the mean? The mean is 80.087. And what is the standard deviation? The standard deviation is 1.519. Okay? Now, what we just looked at is called our population distribution. Okay, we looked at all the 115 powered forwards, okay? Now, if we were in class, actually, you know what, why don't we do this? Before we sketch this dot plot, what I want you to do is take a random sample of 5 powered forwards, and I want you to find their mean. So for instance, the ones that I'm going to take, and I want you to actually write down which ones you used, okay, and there's going to be 5 of them, and then you're going to add them up and you're going to divide by the mean. So what I did is I took 81 plus 82 plus 81 plus 80 plus 78, and I divided by 5, and I got 80.4. Okay, and that's my mean of a sample. So everybody's going to have a sample of 5. Everyone's going to take 5 different players. Okay, they're going to add their height, and we're all going to get different answers. All right, so do that right now. Now, if we were in class, okay, we would come up, or you guys would just tell me what your means are. So I'm just gonna, I did this over and over again, so I'm gonna tell you what I got for all of them. Okay, so I got a mean of 78. I got a mean of a little bit before 79. I got 2 79s. 1, 2, 3. 1, 1, 2. 1, 2, 3, 4, 5. 1, 2, 3. 2, 3. 1, 1, 2, 1. Okay, and I did all this. I did this multiple times, and I found the means of 5 different samples, okay? And this is actually your sampling distribution of X bar, okay? So if we want to label it, sampling distribution of X bar, okay? Now, if I look at this, okay, tell me what shape you think this looks like. So this is actually also approximately normal. Okay, and we can know that without even looking at our diagram. The reason why we know that is because if our population distribution is approximately normal, then our sample distribution is going to be approximately normal. So that's something we might want to write down, okay? So we can say that because our population distribution, and I'm just shorthanding, is normal. Okay, so because our population distribution was normal, then our sample distribution is normal. Okay, and we can also say something about the mean. If I were to add all these up, okay, our sample is going to be the same as our population mean. So, okay, we're going to estimate it. So it's roughly going to be around what our population mean is. And I'm just going to say 80, okay? But what we know about our sample mean is our sample mean, if it's normal, is going to equal our population mean, okay? So if we know our population mean is 80.087, then our sample mean is going to be 80.087. And then our standard deviation, okay, is going to be the standard deviation of our population mean divided by the square root of our trials. So for instance, to find the standard deviation of this, we're going to take that 1.519 and we're going to divide it by the square root of 5. So I got 0.67, so 0.67, it says estimate, so we can honestly say it's really close to 1, okay? But those are two new formulas that we have to kind of remember, all right? And this is for the distribution of sample means. If we know our population mean and standard deviation, then we can find out our sample mean and standard deviation, okay? And now using that, we are able to find out our probability, okay? So use a normal distribution to find the probability of taking a random sample of 5 powered forwards and getting a sample mean less than 90 inches. So if I have my normal curve, okay, my mean is 80.087, and I'm looking at 79, anything below 79, okay? So can you guys find out what the probability is and use your calculator? Okay, so if I go into my calculator, I'm going to go to second catalog and I'm going to go all the way down to my normal CDF. My lower bound is negative 999. My upper bound is 79. My mean is 80.087. And my standard deviation is going to be 0.67. And I get 0.0523. Okay, so normal CDF, negative 999, 79, 80.087, 0.67. Remember, this is your lower bound, upper bound. This is your mean. This is your standard deviation. Okay, when I put that into the calculator, I got 0.05236, so I'm just going to say round it to 4. Okay, so this was a quick lesson. All you really need to know about this lesson is that if my population distribution is approximately normal, then so is my sampling distribution. Okay, and if I have a sampling distribution that's normal, I use these two new formulas. So my sample mean equals my population mean. My sample standard deviation is my population standard deviation divided by the square root of n. And then I can use my normal CDF to find probability. Okay, so make sure you guys copied all this down. Pause me when you need. Answer those questions on the Edpuzzle. Okay. And then I want you guys to do this check for understanding. Now, I think some of it got cut off when I copied it, okay? So you really needed this standard deviation. Your standard deviation is 5.3 minutes, okay? And your mean is 18.5, okay? So I want you guys to answer 1, 2, 3, 4 questions, okay? I'm going to check that you have your Edpuzzle done, and I'm also going to check that you have your check for understanding done. If you have any questions, reach out to me on Remind. Tomorrow during the day, though, I am practicing the SAT, so I won't be near my phone, but I will answer you guys once they are done. Okay? Thank you.